Hello, folks. We are on air. Nice to see you. How are you? Can you hear me?
I can hear you perfectly.
Okay. It's great. It's great. Fine. When I was introducing you, I forgot to mention a very important thing, that Alexei is a maintainer of Selenide framework. But I suppose that many people here at Heisenbug knows this perfectly. Okay. Gil, as I see, you're located in Israel. And
Yes.
I'm following the news, and I see that country is opening. Your country is opening. You are going back to normal life. Is it correct?
We are still not at the normal that we had like a year ago, where it all started, but almost half of the population is vaccinated, and businesses are opening, and even there are a few meetups that are beginning to be like offline, like face to face.
We
miss that.
Yeah, we are missing offline events very much. Alexei, what about you? I think things are not so bright in Germany.
Yes, in Germany, we all envy Gil. But we have a hope. We have a hope that we will soon also get some vaccination, and we will also be able to meet ourselves not only online but offline.
Yeah,
but not today.
Yeah, but it's great that there is hope with vaccination. Gil, I saw in your profile that your first software was written in your childhood using ZX computer, Sinclair ZX computer.
Yes.
And it was also my first computer. And do you remember what random maze USR 0 means?
I remember that I got this very small computer. My grandparents went to England and brought me some kind of toy. They didn't even know what they were bringing me. And there was a connection to a tape recorder. And I remember every day after school, I came back, connected it to the recorder, and reloaded my ski program. There was like a ski program that you had to go through a lane. So like day after day after day, I was tweaking this ski program in BASIC. Still remember it until today.
Yeah, we managed to write not so bad programs using only 48 kilobytes of memory.
Yeah.
Alexei, what about you? What was your first? What was your first computer?
Actually, I think I was also programming with ZX80. Yes, I also had Electronica, I guess. I don't remember the number, but it was one of the first Soviet portable computers. It had also programmed some games from the book and BASIC. And as far as I remember, the problem is it was that when batteries were gone low, then all the code was erased, unfortunately.
I see.
So that was the day when I was learning, this you write code and then delete it and refactor it. So each time the better code.
Okay,
and you need
great.
a tape recorder.
For Electronica, I think you don't have a tape recorder for Electronica. It was only in random access memory. Okay, it's funny.
Very random access memory. Yes.
Yeah, it's funny. So let's get back from good old times or bad old times to 2021, when we have all the modern computers, all the modern software, and testers and developers, and and modern relations with developers and testers. So Gil, you are, as far as I understand, you are going to tell us about how testers should talk to developers about testability of their code, right?
Yes, and in general, how they should talk to developers, because that also, even the how even matters, not just the what. But yes, this is about the discussion and how to influence developers in order for us testers to make our job better.
Okay, cool. Can't wait to see your presentation. So let's go to slides.
Okay. So thank you guys for having me today. I really wish it was an offline, but we do what we can, right? So this session is basically 2 years in the making, but it is about how we can discuss matters of testability in the language of programmers. Now, I've been introduced before. My name is Gil, and you can find me all these things there. The code, by the way, I'm not sure if it appears downstairs, but the code is on GitHub. The examples I'm going to show. For the last something like 7 years, I've been consulting on matters of software for all kinds of people: developers, testers, product people, agile processes, and so on. And I've done that based on my history of, I don't know, almost 25 professional years of being in the software business. And I started more as a developer with a ZX80, but I've been a developer for most of my professional life, but only in this last something like 10 years, I've been starting to get engaged more with testers. And one of the things that I learned, which I think everybody learns that in some way, is that developers and testers don't speak the same language. And I'm going to show you how to focus, especially some of the conversations, to what is important to us. And testability is something that we kind of think about as being a binary, either it's there or not, but it really isn't. Testability is something, it's a quality that is impacted by a lot of things, but at this point I'm going to share how it looks like from the point of view of the developers and what we can do about it. So I think it was like 2 years ago, we have a meetup in Israel when we had like offline face-to-face meetups called TestIL and Testers of Israel, right? And I gave a lightning talk like 2 years ago, and it was called Dependency Injection, and why you should care about it. Now, I didn't mention it for this talk, not for that talk, but also for that talk. I'm going to basically cover things for two audiences: the testers that don't code, and the testers that do code. And basically, it's a slight message to either audience. But the testers do code. Please follow me along with the code that I'm going to show. The testers that don't code, it's not necessary for you to fully understand the program, because it really doesn't matter. But I am going to discuss patterns in the code, and these patterns are very important. So back to dependency injection, which is basically a software pattern. So I had this lightning talk which lasted about 5 minutes, something like that, very short. And for something like 3 minutes, I explained the technical stuff of what dependency injection is. And most programmers know what it is, but most of the audience were testers, and they were looking at me like, what is it talking about? And really, this is a tester's meetup. What is he doing? And after 3 minutes, I said, well, you know what? Forget everything I say. It doesn't matter. It's a technical thing. But what you should really remember from this lightning talk is there is something called dependency injection. It is a programmer thing, but you should know about this because it matters to how you test the code. And that is the point. Basically, this is how it grew from this kind of 5 minutes into what I'm going to show you today. testability matters to us, but the people who are really putting it in are the programmers. So we need to work together to align these things, not you here. So a lot of the time when I'm, as a consultant, a testing consultant, talk to developers, or testers talk to developer, conversation seems something like this from the side of the developers. And when I was a developer talking to other developers, it didn't look like that. And I was trying to understand why is that? Why is it that developers, and I'm going to say developers as a general rule, no one specific, it's not like, but general as a crowd, they don't listen much when testers are talking to them. And I wanted to understand why is that. So there are a couple of things that you should take into account, like go into the head of the developers. First of all, usually, even if you're working in an agile environment, small teams, developers and testers together, even then, and that's the minority of people who are actually doing agile, most organizations are still not doing that, the testers get the code to test after the developers have finished their work. And this is how they see it. I've finished my work. Everything that comes after that is extra work of something that I should be doing something else, like creating new code for something. Extra work means, in our case, is changing code for testability, but also fixing bugs. Fixing bugs is after the work is done. And testers don't get that, right? We're getting like something to test. Obviously, it's not done because it goes back to the developers to fix it. They should see it the same way. They don't. There are other things that developers learn, because the developers' goal in life is something like, I want to create stuff. And obviously, whatever I'm creating is excellent, superb. It's the best design that could be, because otherwise I would continue the work until it was done. And I invest, like every professional, they invest a lot of time and effort in there and skill. So when a developer says, well, this is down, you can test it, they really in their head like said, we've done the best job we can. Yeah, there are going to be bugs, but that's part of life. But yeah, this is the whole thing. Everything you ask me to do now that will make your life, the tester's life, easier is extra work. There's also, and this is something that when I looked into my life as a developer, and I began to see it more and more in other developers as well, the culture and background of how developers become developers and become a professional developers and continue to do that is sort of creating a path where developers see some things that may not be true. Especially in an organization when developers are separate from testers, when the developers push the code to whatever your source control is, Bitbucket or GitHub or whatever, they see it as done. Yes, bugs may come later, but I'm done. I'm now moving on to something else. With organizations that really separate developers from testers, that means that the testers get the code to test like from days to weeks to months after the developers have really pushed their last code in. So they really see it as done. So again, extra work means it probably wasn't done there. It doesn't make sense to me. So there's a discrepancy here. The second thing is, I've been through that as well as a developer. When I started working on my first job as a developer, they told me, although this was like, we're talking about late 90s, and I was in a team that had testers in it, and this was like something completely new. And there was no agile thing yet. We didn't even know what we're doing, but we were doing something like that. But my team leader told me, don't talk to the testers, because you might influence them. Don't talk to them, don't show the code. You might influence them of how they test your code. So they told me, like, you write your code in whatever way you want to write, because that's probably going to be the best way for you to do your job. But once it's there, the tester job is to treat it as a black box. They don't know what's inside, and they shouldn't know what's inside, because they're going to treat it as a black box. Over the years, I came to understand that this translates into not just code inside a component, but if you look at the whole system has an architecture. And this should be kind of blank to the tester. And it doesn't make sense to me because, well, like, we have discussions, the testers know how things are built, right? But more than that, there's this kind of out in the open surprise that the developers think that I'm just coding. It doesn't matter what you code, you should test it. But when they understand that coding, how the code is written, how the code is working, how it's orchestrated, how it's architected, actually impacts testing, they kind of like Joey here open their eyes. This is where the penny drops and they understand, maybe I should work in some way to make things easier for the tester. But there's a way to go until they get that. Because up until now, I told you about how organizations and training shapes developers' minds and what they think and what they've been told and so on. But that's what they've been told. Over the last few years, as I was working with developers, more with testers that were separated from them, I saw that a lot of the way testers work don't find itself into the developers world. Now, I come from, before I was a consultant, I was working for 7 years in a startup, and we were an agile team. So I was a developer and I was a tester. We worked developers and testers together. We talked all the time. We knew how each other was working. And what I'm seeing now are the opposite of that. So separated. And that means a lot of the information that is useful for the team, or for me as a consultant, when I'm coming in and see all the whole picture, I see that the developers don't see the entire picture. What don't they see? First of all, sometimes the developers don't have access to the test plan. It could be a formal test plan, it could be informal, but a lot of the time they don't know how it's going to be tested, in what environment, by what tools, who's going to be the tester at that point, what kind of skills are required to test well. So all these blind spots kind of push them into this kind of black box thinking. Developers, until they start doing testing or some kind of testing, even unit testing, but that's the lower point of it. But any testing at all, they don't understand the cost of testing. And by cost, I mean number of people, the learning involved, the setup and cleanup of environments and data that we need to set up in order to be testing. That's important because imagine there's a task that takes like a month to develop and a month to test. That's the estimation. In the real world scenario, what happens is that the developers develop it for a month and a half. And basically what we have on a timeline is 2 weeks to test. But in the minds of a lot of developers, 2 weeks is enough. It doesn't matter that it was estimated to be bigger. The picture in the heads of the developers is that when it's done, these 2 weeks are done, not only it's going to be tested fully, it's going to be tested fully and well. So all the information, all the scenarios, the important scenarios, all the feedback is going to be back to the developers so they can fix stuff. All these things, the separate boxes, the separate groups of people, the developers really affect stuff on testers, but they don't sometimes have the picture of what they're really impacting. It's basically time and money, right? Even those developers that actually happen to write unit tests and API tests and stuff like that, they should be in a position to save time for the testers because they've already done some kind of automation, right? They are not aware of this time, how much was saved, how much time was freed, so that the testers can spend their times on other stuff. So these are blind spots. These are things that developers are usually not aware of. And in our discussions with them, and I haven't talked about testability, about testing work, these are things that I think are very important to communicate. And in the end, I'll talk about situations where you can actually do that. So basically, I'm going to finish right now, like going down on developers. It's not my idea here, but this is a representation of the mindset. Whatever comes after I finish coding is not my problem. And you know, it really is, right? So, but it's not their problem; it's the team's problem. So over the years, I tried to sum up the mission statements of developers and testers, so we can at least start saying, well, we know what the other guys are doing. So for developers, this is basically what it comes down to. We want, as developers, we want to produce code that works. Yeah. And again, this is something that developers want. It's not that the job title. They actually want to do that. So they want to produce code that works, and they understand that it's going to be needs to be maintained somehow. They need to go back into that code, and they want to have that easy to maintain. Okay, yes, they don't like going into old code, but usually they don't want to go to old code because it's going to be hard and risky and all the things that we know. But they understand their job as something that when the developer comes in the morning, they will look at saying, yeah, I want to do that. This is what I want to achieve. But that's okay for the developers. What is the tester's mission statement? So this is not something that I invented, but again, this is something that I'm showing a lot of testers, and they say, yeah, I can see why this is something in the morning I want to go to work. This is what I want to do. My job is to find as much as I can about the system I'm testing, and I want to report it to everyone who's interested. This could be obviously the customers. This could be internal customers in the company. This would be the team. The developers want to know how much I learned. They actually do. But as you can see, these two things may seem misaligned if we're working like one group against another. So how can you do that? And what I found was sort of easy for me to do was being the translator. because I've done both jobs. I've been a developer and a tester and all kinds of things. So what I find myself doing in teaching testers and developers is trying to understand the other language. Now, the more I'm doing my job, and this is where we actually go into the meat of this session, is that testers should speak code. Now, what do I mean by that? Should testers code? Sure, if they want to, go ahead. But that's not my point. The point is that if I want to convince developers into changing the way they work, and they know that their profession relies on typing code into the keyboard, and this is what comes out, and I want to influence the way they're doing that, I can't treat what they're doing as black magic, not a black box, black magic even. I need to understand what they're doing. One of the things that you'll see is that I know it doesn't supposed to be like that, but developers treat people who understand code differently than those who don't. Like, I know I've been one. I've done that myself. So the thing is that we, as testers, need to have some kind speaking mechanism with them. So for the audience of people who already code, and I'm going to show examples in Java, but these examples are basically examples. The patterns are there. If you understand code, great. You'll be able to have these discussions better, but what you should focus in, at least in my session, is on the patterns, because we're discussing patterns in code that impact testability. And we're going to discuss how to communicate this impact on testability. For the people who don't speak code, first of all, my homework for you is to learn a bit about code. Specifically, not any code. I'm going to show you examples of how to put the foot in the door at the end by asking questions about that. But if you first of all start thinking of code as building bricks rather than magic that developers do, it will be easier to discuss it with them. And by reading code, by looking at code, you'll say, I understand what you're doing here, and I know that these kind of patterns that Gil talked about was actually, I see them here, and again, this has an impact on what we can do and what we can do together. So I'm going to show you demonstrations, like examples of things that are, like I said, there are patterns in the code. Usually you have patterns, anti-patterns, code smells, all kinds of things that developers, when they're explained, when I give training about clean code and TDD and stuff like that, they kind of process in their mind. They say, this is how I'm impacting my work. But this conversation is a bit different because we're asking the developers to help me do my testing work. Hopefully when they do, you'll see that it's also good for them. And I'm going to start with, when I was thinking about it, I said, well, this is kind of so straightforward that every developer knows that code application is something bad. And when I'm saying every developer, like 99% of developers, and I'm talking about from these 99% of developers, most of them I'm throwing a number like 80% do that. They actually duplicate code. So most people know not to do that, and they probably know why they don't supposed to do that. And some of them, a lot of them continue to do that. And all this is with the knowledge of how that impacts their work. But how does it impact our work? So let's talk about that. So code application, what is the problem first? So basically code application is the same code almost completely copied and pasted, or somewhat modified, that appears in multiple locations in the code itself. Now that's a pattern, right? So you have the same code that appears somewhere in multiple things. But what is the impact of that on testing? So basically, like an example I'm going to show you is what happens when code is duplicated, and that means that we need to check multiple scenarios. So we're kind of walking into our black box mind of thinking. Since we don't know what's written over there, we need to check everything. And that's true for library code. That's true for microservices and APIs. Even if the code is the same thing, we don't know what kind of modifications will be there. So we need to test everything. And one of the things that's going to be repeated over time is that we can't test everything. We don't have all the time in the world. We don't have all the motivation in the world. It's going to appear next. So it requires a lot more testing effort, and where testing effort is required, and we don't have enough time, we don't have enough resources, that means that we need to prioritize stuff, and we lose some kind of coverage. I'm not talking about code coverage that is important for us in terms of feature, usability, usefulness, and so on. Risks. We'll test less. If we need to test more code, we'll probably test less than we need to. Let's see an example. I'm going to check into my Eclipse. Like I said, this is going to be a Java example, but the patterns kind of repeat themselves whatever language that you're doing. So like every example in the universe, it starts with a calculator. It really doesn't matter what the calculator is. For the people who are aware, you're seeing a class here with methods called add2, add, and get result. And you see a repository. It kind of saves the data there. You can see the store in DB. But what is important for us in this code? What is important is that we have a method called add and a method called add2, which, if you see, kind of repeats the same pattern here and here and here. It stores things in the database and adds things into the temporary result. Now, in a unit test for that, where's my unit tests? Remember, you can download these examples from GitHub and better view later. That means that for my class, I need to test the add thing and the add2 things because I'm doing it like black box. I need to test everything, and it doesn't matter that the code is duplicated over there. But if we wrote a better calculator, better adder, you see like what we do is what we call refactoring. We put the same code in one place, a function called store and add. And this is basically put in the two lines there and call it the same way. But now the logic is in there. Okay? Now, if we did that, and basically it does exactly the same thing. If we did the unit test kind of thing, so if we did add2, the path of add2, let's see it again, add2 goes twice into store and add, the private method there. If I didn't have enough time and the willing boss that will get that, I have some kind of an excuse to skip over testing add, because it does the same thing as add2. And it's not that I recommend doing that, but consider this is a very simple code, right? What happens if we have like services for that? We're doing the same thing, but with APIs. So this is like the Spring Boot test version, which means that I'm going to test APIs, and I made a couple of shortcuts to do that. But basically, if had full services there, and I would need to create a couple of tests like this, these are similar to those two unit tests, I will actually be more, I'll need to create better setup, more setup to put these things together, and the problem becomes a bit more exacerbated because there's a lot of code there that's going to be duplicated. It's not like this a couple of methods. And if you look at code, like real code, legacy code, other, you'll see these duplications a lot. Like I said, most developers know it's not going to, it's bad for them, they do it anyway. But services we'd like to test to be written like this, and the way to get there is to do the same thing, refactoring, folded the code into one place. So the problem is everywhere. It impacts library code, it impacts service code, it impacts testing. You'll see a lot of automated tests are duplicated. Most tests that you write, and it comes from the level 2, from unit test to end-to-end test, regardless of what automated tests that you're writing. A lot of the time you'll see that a lot of the code that worked for the first test is copied into the next test, modified a bit, and nobody's folding those into the same test. Now, this is not a testability problem because you're in charge of the test, but this is a maintainability problem. It's going to bite you either way. So, like I said, the problem is that we have some code appearing in multiple locations. There's a solution for that. We need to identify the pattern, like in most of the things that I'm going to talk about. And the solution is to identify it and refactor it. And when you refactor it, like I showed you an example, if we fold the code into one place, it impacts testability because, like I said, if we need to prioritize cases for testing on very complex code, it will be easier for us, A, to prioritize, but to have our confidence built that we're testing more of the code because we know how it's written. And if you hear the but, which is what the developers will tell you, usually here you won't hear any buts. You hear like a silence that says, yeah, I know I'm wrong. I should do better. But the rest of the things, they'll have other things to say. So that was the application. Let's talk about visibility. Now, visibility is important in all kinds of tests, but I'm going to focus a bit more on automated tests. Usually what this means that you cannot call code directly or access parts of the code or memory or some kind of memory or data. So you can assert on that. So you want to test something, you want to execute the code, whether it's an API or a subsystem or whatever, and you want to see the results. So if you're looking at it at the end to end, sometimes you won't see any result. Something like you posted something, but you won't have any access to checking that the post result was actually happening. You might need to write a setup for that. Like, let's say you have an API that saved something to the database. You need now, if you don't have a get API formed for testing what happened, you'll need now to look into the database. That is complex. This is something that requires more effort. And when it does, like most thing, more setup effort means less coverage. The bigger the effort, that means that we'll reprioritize things and things will go down untested. Let's see an example for that. Going to close everything and go to example 2. Okay, so we've learned from our mistake in the duplication, so we don't have any duplication here. We also got rid of the database in this example. Because what is interesting here is that when you call add of two numbers, the add 2 of the last time, it does two things, one with A and one with B. Now, that's nice, but let's look at our tests. So when I call add with two numbers, I still have the get result, which is a public method. I can get the result in, so I have a getter method. But you look at the code again. The get result will return the value of the temporary result. Okay? And the temporary result is updated twice here. Now, if I wanted to see what's happening between these two lines, I need to do an effort. As a developer, yeah, sure, I'll debug. I'll put a breakpoint there. I'll show you what's happening. Not good enough? Right, I'll write a log for you so you can see what happens with A and B. But sometimes you don't have this kind of service from developers. Like I said, they're not willing too much to do stuff for the testers. So the code as it is, it hides stuff from you. So if we look at a better header, all I did was basically made the internal method public. I can now access it and test it separately. So if I look at if I had a couple of things, so the first thing checks two numbers which I can't get into. But with a better header, I can call also the internal method and see that it's working. Cool. I kind of added more tools to my inner glasses looking into the system. So that's cool. And the whole costs that the developers had to add was change that to public. It will cost us, trust me. If we're talking about services, like I said, you may have a post, but if you don't have a get URL to check the current result, you need to jump through hoops to get this to write an assertion for it. And the equivalent of the code before was like add an API. Now, adding an API is sort of an effort right now, right? I'll need to create the API and approve it. And I may need some kind of authorization policy, so only testers can do it and not everyone. It's an effort. But this effort, if done somehow, will result in our ability to better test the system. So what is the solution? Make it public, like the name of our public enemy pictures slideshow today. Expose stuff. Either through public methods and functions or through API. Allow the testing machine, the tester, the test code, to get this information, and not by parsing logs. Now, here is where you start hearing like objections, because this is not something that developers take lightly. First of all, there's the ultimate risk factor. Someone may call it. I'm putting something to be public. Somebody may call it, and that is true. Okay, we kind of figured out that someone needs to call it, us, right? So it has a cost and it has a risk. But first of all, turning something from private to public, or similar in anything, could be like package visibility in Java, which Java has, but C++ doesn't have. It has some kind of cost. Usually, if this is what programmers see as their gateway into the code, and that's the only gateway and the only policeman that is going to pass you around, that's not a good idea. But it does require some kind of authorization policy. If something needs to be visible, make it visible. If you had like let me jump to the code again. This is for the people who know code. This is a private method. I could extract it into another class, and it will be public there. Okay, that's how you refactor into other classes. Extract method and extract class. So when you do that, you make this code public in another place. So the language, the infrastructures, the mechanisms are there. We need to discuss what we gain against what it costs us. And a lot of the times I'm saying, yes, it should be public because the risk is not that much when it calls for that, and the value is a lot.
May I ask you a question?
Sure.
Alex is here. What is your opinion on doing the technical tricks like using reflection API to access private methods or fields without changing them actually in your code? So you probably know there is many cases possible.
Okay. So technically it's possible. It's possible in some languages. Let's start it. We're talking about Java. So Java and C# allow reflections. Other languages may not have that. Is it possible and technically possible? Yes. But you need to know two things. First, you need to understand reflection. And that's not something that I found that most people know. So that's the first thing. You need to know that it's there and what you can use it for. The second thing is that when you're using reflection, you're not using the APIs or the methods of the code. And that means the test can break because you're changing the structure. You're looking into some field named name. Well, somebody may have changed it or renamed it to something else, and the tests were not aware of that. So, and you're maybe changing the method. You're looking to operate a private method called calculate, but it requires 2 parameters rather than 1. So tests that use reflection are basically more fragile than regular tests. So as long as you know what you're doing, it's kind of okay. Okay, again, unless you have API to call, which is the preferred way. But remember, the person who comes after you and replaces you and get in charge of those tests may not be the genius that you are and understand what the tests are doing and what they mean. And when they break, they will say, well, I don't know what to do right now because what is these fields that do not exist there? So when I'm saying you need to know what you're doing, it's not just you, it's just the people who will come after you. If it's a team knowledge, it works fine. I worked in a team that understood I worked in C#, so understood the IL, the equivalent of bytecode. Like this was our profession. So we knew exactly how to operate code like that, and reflection was our bread and butter. So when we saw reflection code, it was like regular database code for us. If it's like that, no problem. The skill is in the team. If it's just one person doing this and writing that, there's a risk that after you moved on to be a team leader somewhere else, the team will not be able to operate, and the tests will lose their value.
Thank you very much. Thank you very much for the answer. May I ask another question about the application?
Sure.
I've missed a moment probably, but look, let's imagine we have a typical situation with overloading. You have two methods. Let's say one has two parameters, and the second is without parameters, but it just uses the first method. And let's imagine you have no duplication, everything is fine. What is your opinion? Would you write, so basically, if you, both methods are public API methods. So no help methods, but both are needed in some places, yes? And would you write just one? So there is a possibility if you just call the one method without parameters, you are indirectly also calling the second method with parameters. So you have 100% coverage even with one test. Would you write, but I think there are also arguments writing two tests, so it is interesting to know your opinion. Would you recommend to write one test or still to write a test for both methods?
If I have time and it's easy, I would cover every public API in multiple case scenarios, okay? Because everyone can call these public methods. That's cool. If I don't have all the time in the world, I will look for shortcuts. And these shortcuts are based on how I understand the code. And this would be like testing the big overload, which kind of covers the smaller one. Because the thing in my mind is, if there's going to be a bug, it's still going to operate that code. Okay, so I can pick one of those. And again, you can twist my arm and tell me, well, maybe one is called more than the others and so on. I'm going to take that into considerations. But as a rule, test at least cover everything that you're confident in, that you expose. If you don't have that luxury, you need to prioritize, and then it's going to be based on the code and what makes sense.
Thank you very much.
Sure.
Now, let's continue.
Yeah, we have 20 minutes, and I'll speak a bit quickly. Dependency injection. Okay, so I talked about it like 2 years ago when it all started. What is dependency injections? Code is complex, and we're kind of calling a lot of things in our code, and we call them dependencies, and our code works with them. Now, sometimes these dependencies are embedded and created in the code, and we can't replace them. When we can't replace them, we're kind of missing opportunities to mock them or replace them or make testing scenarios easier to write. If they're not easy to write, we probably won't write them. Let's see an example. By the way, dependency injection is kind of a fancy name for passing things from the outside. Let's see. So kind of our calculator from before, notice this line that goes into the database. So this one creates a repository inside the code. That's the only problem with this, in terms of dependency injection. Dependency injection basically is a mechanism to control the dependency. And basically, whatever I do, and let's look at this repository code, for example, it just goes to the database and stores things of the database. Really doesn't matter, but it's tied to the code. So if I look at my code here with the tests and I use this header as is, it will go to the database. And that means that I need a database and I need some kind of configuration that gets me into a database and a lot of setup that basically to pass, not to break, not even pass, not to break this code. Because remember, what is it doing? It's not even concerned with the database logic. It basically looks at the temporary result. So the repository stuff is just like in the way. But in order to run this scenario, I need a database in place. So what is dependency injection? Or better, header gets the header repository from the outside as a parameter. Here I pass it as in the constructor, but it doesn't have to be. It's not created inside it. If it's created here, I can use in a unit test kind of way, Mockito here, to mock it. That's basically it. If we're talking about APIs, we have code that calls code that calls code. Basically, it goes together like that, and I need to make sure that our servers, like if our controller calls another controller, which calls another controller, everything is set up just for the test to execute rather than we're not in the path yet. But if I'm able to use Spring as a dependency injection framework or some other way to mock or to divert and disconnect these dependencies, my life as a tester becomes much easier. So what is the solution? First of all, we need to create a dependency from outside. This is changing the code for testability. Dependency injection is part of the main ideas of the solid clean code principles, but like I said, developers sort of know that, but it doesn't. This knowledge doesn't always work. But the good news is a lot of us are working with frameworks that have this internal, like the Spring in Java is a dependency injection framework. You can just embed all kinds of things. You just need to auto-wire these things in the code and things will work. Or set up services to talk to other services and load them through Spring as different beans. Break the dependency. That's all there is. If you're using Spring in your team, you're already doing that. You have the tools, you have the capabilities, probably have the skills to understand that. You have dependency injection in your hand. But still, I saw a lot of code that actually creates something inside it, and they just go together, and the code breaks under tests. The example I saw, by the way, is calling a mainframe directly. So these can be replaced, they can be mocked in different scenarios. And this is what you see. Well, I designed this code to work like that. It works like that. It already works. I've proved it to you. Why should I change it? And the thing is that if it's not testable or easily testable, if you can't prove it that it works under test, then it's not very good design, is it? So, and by the way, for the people who use Spring is a dependency by itself. If to run Spring code, you need Spring. Otherwise, things will not be there like beans to come up from to be run. So you need to invest in that as well. Mockability. So mockability is kind of a continuation of dependency injection, because dependency injection opened the door to mock things, but sometimes you can't really mock them. So yes, dependency can be created from the outside, but they are not written in a way that could be extended. Mocking is some way of extending code. What is the impact? If we can't mock, if we can't replace, same problem that we had with dependency injections, the code will either break or will not pass. And that means, again, either we put some effort into creating complex setup, or we simply don't, and we don't cover these paths. Example. So we have an header, and it has an inferior repository because it's inferior. Let's look at that. The database, yeah, it goes into the database, but you'll see that it has final is-it. Final in Java means you can't extend it. Why? It was written that way. Somebody has decided, the minute it puts final in it, you can't use Mockito to mock it. Let's look at the code. If I'm using it with inferior repository as is, I can't mock it. It will not compile. If I remove it, if I remove the better repository, look at the better repository, doesn't have any final, I can actually use a mock in order to mock it. Now, mocking is one way of doing that, like Mockito here, but it is a design choice. This is an example of a design choice by the developer. Could be a third-party developer. It's not even something that you've created in your team or your organization. Somebody has decided that this is the way to go, and kind of created a stop in your testability machine. So what can we do about it? Sometimes you can't put something, you can't do this, and you have to put adapters in. That means, again, changing the code so you can replace it. Sometimes it is within the realm of possibilities of developers to do that. Sometimes in terms of, let's talk about scenarios of APIs. It's hard-coded in the code where some code goes to call an API, and this is like, you can't do that. Well, but if you can reconfigure where it goes, you can mock it, like using wire mock or something like that. So the mockability thing, a mockability word is something that I think I invented this word. But the thing is, if you could replace dependencies and create them easily for testing, it's a good way to go. If you can't, because the code doesn't allow you to do that, you're in more trouble. So whatever, when you're as a developer doing that, if you have choice over that, don't make these things final. What are these things? The things that are dependencies that are hard to manage. It's called final or sealed or whatever. You can use dependency injections. If you're working against a database that is, you need, I don't know, SQL Server for that, and you need a whole setup for that, it would be a lot easier to work with an in-memory database like H2 to create integration tests or end-to-end tests that are highly replaceable. You can switch different scenarios, run different data. You don't need the entire schema. You need just the things for the tests, depending on the scenarios that you need. You need to plug these things apart and see if you can replace things. If it's not, it's going to cost you. Again, these are the same things that are will come up from the developers. I believe we have 10 minutes. I'm going to skip but the last one I prepared, which is modularity, which in a couple of sentences break things down and the setup becomes a lot easier. You can look at the code examples on GitHub. I want to finish this by saying how to have these conversations and then leave probably 5 minutes for questions. So you can check out the slides and the examples later. How to be part of the conversation. I mentioned that before, that if you're having the conversation after you got the code, it's too late. The developers have already written it, they've designed it in some way, and you'll find that things are hard to change, especially because of the things I talked about earlier. So the conversation has to take place before development, during development, and after. So this has to be an ongoing effort. It's not something you can do at the end. And the idea is that we all have all kinds of, we all have some kind of either formal or less formal or a non-formal way to do stuff. And whatever process we have, we can put more people in there. Especially, I'm talking about design reviews. Thank you. So design reviews, code reviews, these look like developer meetings. Testers should join them as well. Test planning, test design, test reviews looks like testers meetings. Get developers theirs as well. Ask questions, and these questions will let you into the developer's world by showing what's your interest. Ask, where is the risky code? You have a lot of code there. Where's the risky thing? Where's the logic? Where things are going to be buggy? Things that you probably already ask. If I'm changing this code, what other features are going to be impacted? What kind of dependencies are we using? Third party, is it our code? Is it a driver? What can we do to replace it if we want to test these things apart? Will we be able to mock them? These were design questions. Talk about planning the process itself. What are you going to automate when I'm getting this? What was already tested? Like this works. What kind of tests are you already providing me with? What they don't cover. What I need to understand, which is you haven't covered it, I need to test. What is the cost of you changing this so I can test it? And what do we get in return? Because if I can test it, we'll get more information about this subsystem or system. Retrospectives, if you have them, is a great way to have this discussion, because you can ask what made this hard or easy to test. You can define what hard and easy and explain what it is hard to test and what is easy to test. So we're getting to the end. I want to finish by a quote from Mike Hill, G. Paul Hill. This is something he wrote like 5 months ago. He said, if you brought a talk to developers, if you brought us the functionally correct design that requires our app to run on 1 million virtual devices, we'd casually say it's not a valid design. Now we need to discuss a testable design as valid design. Otherwise, it's not valid. We need to help the developers do their job, because it's not their job. It's not my job. It's a team's job to create something working. We want to help the developers because that's our only hope. Thank you very much for today. You can get to me in all these things, including the Telegram that isn't here. You can have the slides probably on my profile page, and you can get the link to GitHub there as well, and you can download and look at the examples. And for whatever time we have, let's try to take some questions.
Do we have time for one question? Vanya, we cannot hear you, or at least I cannot.
I'm guessing we have 4 minutes.
Okay. I don't hear Vanya. Okay. So I will ask you a question from the audience in case you can hear me. Yes. Okay. So from Konstantin, I will put it this way. Could you show what would be the difference between just rules of good OOP, like solid to other rules? Difference between good OOP or what we were demonstrating in this talk?
Sorry, folks, I was muted. We have only 30 seconds left. If you, Gil, can answer in 30 seconds, then answer it now.
I don't
or
think
else...
so, but if we can move into the Zoom session, I can.
Yeah. Sorry about that. Yes, we're short of time, and there are actually questions in chat, and there are certainly questions to discuss in Zoom chat. Thank you very much for this motivating talk.